In our previous discussions, we have taken EMF induced in a particular conductor. That conductor means a coil side of a singleton coil considered here as E. Irrespective of the location of conductor anywhere under the pole face, north pole face or south pole face, the magnitude is taken as E, constant. Sometimes conductor is lying here, sometimes conductor is lying here, or sometimes conductor is lying here or anywhere. So in short, we considered the magnitude of EMF induced in a particular conductor. That particular conductor is forming one coil side of a singleton coil, is constant, taken as constant, is equal to E anywhere under the any pole face, whether located here, 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 here. How? Today we are going to discuss it in detail now. EMF induced in a conductor of length L moving with velocity V in a magnetic field B is given by E is equal to V cross B dot L. Position vector. Let us take L as position vector. So let us take a simple example of a single turn coil. So let us make here a particular slot and place one conductor in this slot and diagonally opposite another one. Let us take here and place the other side of conductor here. Means we have taken let us take this one coil. This length is L. Let us take this length as L. So cross sectional view, you can see this and this. So this end is here and this length is placed along the parallel to the shaft of this in the slot, and here also this side is placed here, and from back side these both the conductors forming the single turn coil is connected from back side. So as we can observe that the flux lines are crossing the air gap in such a way that the reluctance offered to the flow of flux lines are minimum. That's why we can observe all flux lines are not parallel. They are following shortest path in the air gap. Means at any point on the surface of rotor, if you are going to draw tangent at that point, so you will find that these lines are perpendicular to the tangent drawn at a particular point everywhere under the north pole face. Similarly for south pole face, you can observe. So we may say that if conductor is here, then velocity will be this way and this is B. So for this present position, if velocity is this way, take tangent and B is perpendicular to that, this. So V cross B, as discussed earlier, rotate V towards B. So this will be coming out of the plane. Movement of this pinwheel is coming out of the plane like this. Rotate V towards B and observe the movement. It is coming out of the plane, or Fleming's right hand rule also you can apply. So you may mark the polarity of the EMF induced in conductor, because this rotor is being rotated at omega radian per second in anti-clockwise direction. So that's why velocity will be this, right? Similarly, if at this point, if you are going to take V, so V will be this way and this perpendicular, right? So you may mark like this. Suppose at this point you want to take this, so this will be velocity and B is this way as shown. This is B. So V and B both are perpendicular. Similarly, at any point, let us take this point. So here this is V and this is B. So we can observe that V and B are perpendicular to each other anywhere under either North Pole or South Pole throughout the pole phase. So V cross B sin 90 will be 1. So V into B, and this length, so position vector will be towards this dot itself. Dot means pointing towards this way. So dot product in the same direction. So cosine 0 degree, that is 1. So finally we will get VBL at any position under the North Pole phase region or South Pole phase region. We will get this as constant. Clear? When this conductor reaches here, throughout from here to here, EMF induced is E. As soon as it crosses this position, suppose this conductor reaches this position. So at this position, velocity will be this, direction of velocity will be this, and magnetic field direction will also be like this. How? See, following minimum path, you may see that inside this will be like that, from here like that, like that, like that, like that, like that, like that. So you may observe under interpolar region, the direction of B is along the direction of V. So cross will be sin 0, will make it 0. That's why the EMF induced in the conductor along magnetic neutral axis, this will be along this, will be 0. What about this? So this conductor is always along the magnetic flux lines. The conductor used to connect the two coil sides, single turn coil sides, two conductors from back side. So always here EMF induced will be 0. Similarly here and here this will be 0. So total EMF induced across these terminals will be this EMF. See the polarity. So if this is plus, this is minus. What about this side? So again, from cross product V cross B. So V cross B, if we are going to rotate V along B here, this side, so rotate this, so this will move into the plane. That's why mark cross mark here anywhere. So this direction will be like this, plus and minus. So if this EMF induced is E and length of the conductors on both the slots are same, is same, then here also it will be E. Let us mark here EMF as E. So total EMF induced will be 2E. So if you are going to plot EMF induced across this, let us say this is V armature, ARM, let us mark it V. This is plus, this is minus. So this is equal to 2E. So let us plot here. So let us, this is 0 degree. So at 0 degree, let us start from here. So mark it at 0 degree. So from here till here it will be 180 degree. So from here till here it is starting from 0 and reaching some E value. So we are taking this. So E here also, when this reaches here, this reaches here. When this conductor was here, so this conductor was here. So drop across these two ends is 0. So let us mark here like that. then again it comes under a pole phase, say north pole phase, and then reaches here, then again here 0, so it will approach to 0. Again, as soon as it reaches here, it will start, and this will be the, again repeat the same, first repeat, then we will mark the points, and so on. So this is 0 degree, this is corresponding to 180 degree, this is 270 degree, not 270, this is 180, then this is 360, right? One complete rotation. So again, and so on. Here, mark the V armature. Let us represent V armature, and this value is twice of E, where E is VBL. Fine. Now let us connect commutator segment. Let us connect commutator segment. Let us mark here. So here we are going to connect the ends of the conductor. So let us take two segments of the commutator and connect this conductor with any commutator segment and this conductor with the other commutator segment as shown in the figure. Let us represent our brushes. Let us take this as X terminal and this as Y terminal and mark the commutator segments A, B. So we have considered the case of 4 coils, single turn coils, double layer winding. Here just we are going to consider a single turn coil, single layer winding, simplest one. So we can observe that at this moment, this terminal is connected with positive terminal and this is connected with negative terminal. After 180 degree, when this conductor reaches this position and this conductor reaches this position, what will happen? These brushes are sliding on the commutator segments. Commutator segments are rotating along with the rotor. So at that moment, B will reach here, means this brush will touch B and this brush will touch A, and again the positive supply will be connected with this terminal, right? Because whenever this conductor reaches here, the EMF induced is reversed, dot here. So in that case, the positive terminal again connected here, and in every case we can observe that we are getting unidirectional supply across X and Y. That is, if we are going to plot the EMFs across XY across the output terminals, then we can see that we are getting our EMF. Let us represent this as twice of E. So we are getting, no, this we have plotted without rectifying, right? So this is basically plot of this VXY, because this has been reversed, rectified. In earlier case, when this was not rectified, then whatever EMF induced across the terminals was there, the polarity was reverse here, whatever it was here. So let us draw, which we tried to draw earlier. This is the present case VXY, and earlier V armature. So this will be like this. And so on. So mark the points. This is 180 degree. This is 360 degree. And this is 540 degree. So we are taking the EMF induced across these two terminals. So we will get like this. When it comes under north pole region, we are getting positive polarity, means potential of this is higher than this. When it comes, suppose this rotated 180 degree further, then it reaches here. In that case, potential of this will be lesser than that. So negative will be obtained and like that. But after rectification with the help of brushes and commutator segments, we will get this wave shape, means this is positive, okay, and this negative will come here and this negative will come here, means unidirectional. So this is Vxy, voltage drop across the output terminals X and Y after rectification of the EMF induced. This EMF is alternating in nature. You know what does it mean? Alternately, this wave shape may be any wave shape. Here we are getting like that. Alternating means some positive, some negative of any shape we are getting, right? Hope it is clear to you. So this was all about function of commutator, how it works.